Welcome to functions and graphs. Let's first talk about the parts of a graph. This line here, going up and down, is called your y-axis. This line going across is called your x-axis. Okay, if I were to number them, I have 1, 2, 3, 4, and so on. These are your negative x, so that's -1, -2, -3, -4, and so on. For your y's, this is your 1, 2, 3, 4, and this is your negative y's. This is your origin right here, or your 0. Below your origin on your y line is your negative, -1, -2, -3, -4, and so on. We can have a point, which this would be point 1, 2, 3 on the x-axis, and that's a +4. This is called an ordered pair. If I were going to see, I can look at my ordered pairs in a table. Well, your x, y. If I had 1, 2, these are just examples. All your x coordinates are called your domain, and all your y coordinates is called your range. So I can also write them as 1, 2 as an ordered pair, 3, 4, and 5, 6. And that tells you where to find them on your graph. If I were to graph 1, 2, I'd go over 1, up 2. 3, 4, I'd go over 3, up 1, 2, 3, 4. We already have that. And for 5, 6, I'd go over 5 on the x-axis and up 6. And that would be my 5, 6. Now let's talk about which one would be your independent and which one would be your dependent, and how exactly you would know. And I'd like to use some real-life examples in using independent and dependent. As a general rule, your x-axis or x-coordinates are your independent, values, and your y-axis is your dependent values. Just as a general rule, when discussing, we really like to take a look at real world problems. Let's take a look at this one. The distance a person runs increases with time. Now I'm going to tell you right now, time always goes on your x-axis. So we know right off your bat, your independent would be your time, and the other number in here is the distance, and since time goes on your x-axis, distance goes on your y-axis, so your dependent would be your distance. And let's kind of make some sense of that. If I run 1 mile, which will be your distance, let's just say it takes you 2 minutes to run 1 mile. If I run 3 minutes, I'm going to run 1.5 miles. If I run 4 minutes, I'll run 2 miles. So when the time changes, the distance will change. And that's why we say the distance you go depends on the amount of time you go. And that's why distance is dependent upon your time, just like you depend on your parents, okay? Or just like you depend on your job. Your independent would be your time here, and your dependent would be your distance. The reason we go over this is because we are going to take a look at how to analyze a graph. And analyzing graphs are one of my favorite things to do. I'm going to go ahead and insert a picture here of a graph. Okay. And I have time, amount of time, and speed. Time always goes on your x-axis. So the other numerical value, which in this case is speed, will go on your y-axis. Let's talk about what happens with a bus. Okay, let's go ahead and start the bus. We're going to accelerate as our speed goes up. The time is always moving forward. Now he's maintaining his speed. Where's my dot? Okay, then he slows the bus down. Time is always going forward. He stops the bus, but to pick up some kids, because that's what buses do, but time has to go forward. And then he accelerates again. It goes faster. Maintains his speed. And then slows down his speed. And he stops the bus because he's at school. Okay? And it goes on and on like that. Time never stops. So that is the graph of a bus. Okay? Here, once again, time goes on the x-axis. And this time, I'm going to put temperature on the y-axis. And we're going to graph coffee. And so you don't forget, this is the bus. Okay? Now, what happens to a cup of coffee? Say my cup of coffee. The temperature is going to start high because it just got out of the microwave. I like to heat up my coffee in the microwave. So it's going to start high, and it's going to gradually go down over the amount of time. Now, while you're doing this, a lot of people would go ahead and graph to 0, but it's not really going to go to 0 temperature. It's going to eventually gradually go off to room temperature. Here's your room temperature. And it's going to stay at that room temperature. Okay? It's not going to get frozen unless it's put into a freezer. And I'm not doing these in the freezer. And these are examples of analyzing graphs. In a discrete function, you have points on a graph, almost looking like connect the dots. It is not connected. Okay? Where a continuous function, you still have dots or points, but those points are connected. So in other words, that's why it's called continuous, because it's connected. No, that's a T. No, D. And that's pretty much the difference between a continuous function and a discrete function.